unfortunate, but when I woke up that morning, I thought it was going to be a bad day. Just having a full night of rain is not good in the trenches. That it was completely understandable why someone would go in around there. They said, well, the concrete guys, the form guys have been in there all day, and probably all week and had nothing happen. So they thought, well, just uncovering the sewer stuff would be no problem. That was a big mistake, because you could be standing in a 4-foot deep trench like this person was, not very deep at all, but at the same time they were undermining an embankment that was 15 feet tall. So essentially he was 19 feet deep, and that doesn't wash well when you have soaked soil for the whole night. So you can get a guy who's been working the trade for 20 years, and I've been in that situation every day for 20 years. And that's the time when he gets nailed, because he's got a false sense of security about whether the soil's stable or whether they've taken the proper precautions. Of the things that seemed to stand out the most from that day it was totally preventable. Unfortunately, no one saw that, I guess, on the job site. I think that they knew that they were out of compliance, but when does common sense and safety take over? And that was what they obviously missed. Consequently, they got a dead brother.
Unsafe excavations kill people. Every year, about 400 U.S. workers die in trenches, and 6,400 are seriously injured doing the work we do every day. That's why you need to understand trench hazards and how to prevent cave-ins. OSHA, the Occupational Safety and Health Administration, has a standard on safe trench procedures to protect you on the job. This program is going to teach you how to classify soil, work in protective systems, and spot excavation hazards. First, what is a trench? It's an excavation deeper than it is wide, but no more than 15 feet wide at the bottom. An excavation can be wide, like a block of high-rise basement, or one-sided, like a borrow pit. What all excavations have in common is the potential to kill. You see, when we excavate, we know the walls will fail. We just don't know when. In its natural state, soil stays in place, pulled by horizontal and vertical forces. Excavate, and you've disturbed nature. Soil moves downward and inward to heal itself. When soil starts to cave in, cracks cause the bottom third to fall first. If you are working when the walls fail, you can be buried up to your knees before you know it. And if you're buried up to your knees, you can't get out without help. You see, soil is heavy. An average cubic foot of soil weighs 100 to 125 pounds. Some soils weigh up to 145 pounds. With the suction effect, pulling out one buried worker's foot can take 750 pounds of force. Your body's just not built for that. Or suppose you're buried to your chin. Your chest must move 800 pounds of force to get air in and out of your lungs. What happens is suffocation. Your chest can't move in or out, so even if the dirt doesn't get in your mouth or your lungs, you'll die when you can't breathe. There are other ways workers can be killed in excavations. Objects fall in on them. They drown. They're crushed and suffer massive internal injuries. To keep you safe in excavations, OSHA requires soil classification by a competent person and installation of adequate protective systems before you enter the trench. A competent person has enough training to identify excavation hazards and authority to take prompt corrective action. The type of soil determines the selection of safety system. OSHA identifies soil types as stable rock, A, B, or C. In practice, you never work in stable rock, since excavating makes soil unstable. Type A is the most stable class of soil. It is dense, heavy, and resists penetration. If it dries out, it will develop cracks. Clay, silty clay, and hardpan are examples of Type A soils. Type B is the next most stable and is made up of soils like silt, sandy loam, medium clay, and unstable dry rock. Type C soil is the least stable. Gravel, loamy sand, soft clay, submerged soil, or unstable rock are all examples of Type C material. Actual classification requires a competent person to identify grain size, saturation, cohesiveness, and unconfined compressive strength. Soil falls into 4 basic grain sizes: gravel, sand, silt, and clay. Gravel is the least stable, and clay is the most stable. Basically, if a grain of soil is larger than a pencil lead, it's gravel. Smaller is sand, and your naked eye can't see particles of clay and silt. In general, the bigger the grains, the less stable the soil, and the more careful you need to be. When you're dealing with water and clay or silt, a certain amount of water makes the soil stable, but too much water causes cave-ins. So along with grain size, the amount of water in the soil must be considered. Soil is made up of rock broken into tiny grains separated by voids. Soil voids fill with water or air. Saturation refers to how much water is in the voids. If the voids are completely filled with water, we say the soil is saturated. If the voids are completely filled with air, we say the soil is oven dry. This dried out soil fissures and spalls off the sides of the excavation. Anything in between dry and saturated is referred to by the percent of saturation. Keep in mind, the more saturated the soil, the less stable it is, since soil slumps and shears off faster when it's full of water. That's why we look at the stability of soil, or its cohesion. Soil stability refers to how well grains hold together and is called cohesion. Cohesion predicts how well the walls of a trench will hold together, or how quickly they'll collapse if unsupported. Unconfined compressive strength refers to how soil reacts under pressure. Soils that readily shear off trench walls are more hazardous than those that hang by tensile strength. Unconfined compressive strength is measured as the amount of weight per square foot required to collapse a sample. Soil is tested visually and manually by a competent person. With experience, you can recognize some visual clues. As you come on the site, look at soil particle size. Remember, if it's larger than pencil lead, it's gravel. Gravel can be Type B or C. Angular gravel is Type B, and round gravel is Type C. If the soil particle is the size of a pencil lead, it's sand and Type C. If particles are invisible, the soil can be silt and clay, which could be classified Type A, B, or C. But remember, no natural soil is made up of all one-size grain, so you'll be working in mixtures. Next, notice if the soil clumps when it's dug. This may indicate it's clay and silt. Cracks in walls and spalling can mean the soil is Type B or C. Layered systems in adjacent hazardous areas such as buildings, roads, and vibrating machinery require special consideration and possibly the services of a registered professional engineer to determine soil type. Water standing in the bottom of the trench or seeping through walls automatically makes the soil Type C. You now have a rough idea of soil type, but manual tests are required before protection is selected. Sometimes soil samples are sent to a lab for testing. Sometimes they're tested on site. Whatever method is used, soil is always tested as soon as possible once the sample is removed from the ground to preserve its natural moisture. One warning: testers never enter any excavation to test soil. Soil is first dug out and a representative sample is gathered from the spoil pile. Tests include a sedimentation test that shows how much silt and clay is found in sandy materials. For this test, A sandy soil sample, after removing gravel, is placed in a straight-sided jar with about 5 inches of water. The sample is thoroughly mixed and allowed to settle. Sand settles off in 30 seconds, and a sample with 80% sand will be classified Type C. The wet shaking test identifies the permeability of the soil. You can see as the sample is shaken, clay resists water movement through it, while water flows freely through sand and less freely through silt. The thread test is used to determine cohesion. For this test, a disturbed sample is rolled out to 1/8 inch diameter and picked up. If a sample holds together for 2 inches, it's considered cohesive. Clay and silt behave similarly until picked up. Silt breaks off before clay does. A ribbon test is a backup for the thread test, since it is unlikely to be affected by one stray piece of gravel. A sample is rolled to 3/4 of an inch in diameter and squeezed between thumb and forefinger into a flat, unbroken ribbon 1/8 to 1/4 inch thick. As it is formed, the ribbon is allowed to fall freely. If the ribbon does not break before several inches are squeezed out, the soil is considered cohesive. When soil type is known, the right protective system is chosen. Basically, employers may choose from sloping and benching or shoring and shielding. Sloping and benching cut the walls of an excavation back at an angle to its floor. The sides of a sloped system are angled cuts, while benching uses one or more steps. The flatter the angle, the greater the protection. The choice of a slope or support system is based on soil classification and the restrictions of the particular excavation site. Type A is the most stable class of soil and holds together when wet. Clay, silty clay, and hardpan are examples of Type A soils. The ratio of slope established for Type A soil is 3/4 to 1. To determine the slope of a 20-foot trench, start at the trench floor. For every vertical foot rise, the wall of the trench must be cut back 3/4 of a foot. The benching system for Type A soil, with a 3/4 to 1 ratio, will have steps 4 feet horizontal and 5 feet vertical. This forms a step system that can be repeated to the top of the excavation. Type B, the next most stable, is made up of soils like silt and sandy loam, medium clay, and unstable dry rock. The ratio of slope for this soil is 1 to 1. Every horizontal foot run must have a vertical foot. Benching in Type B soil at the 1 to 1 ratio means that each step will have a 4-foot horizontal run and a 4-foot vertical rise. This will form a multiple bench system of protection. Only cohesive Type B soils may be benched. Type C soil is the least stable. It is made up of gravel, loamy sand, submerged soil, or unstable rock. Type C soil needs the flattest angle of slope. With a ratio of 1.5 to 1, the wall of the trench must be cut back 1.5 feet for every vertical foot rise. Due to soil instability, Type C soil is not benched. Sloping and benching diagrams are based on good trenching conditions. Factors like weather, traffic vibrations, and pressure from nearby loads, called surcharge, make soil less stable. A sloped or benched excavation should be re-inspected for signs of distress after any increase in such disturbances. Cracking in excavation walls, bulging of material from its bottom, or separation of small clumps from its sides can indicate a potential cave-in. You will be directed to leave the hazardous area, and the slope will be cut back farther. Shoring is designed to prevent cave-ins by supporting walls with vertical shores called uprights. Horizontal members along the sides are wales, and those placed horizontally between trench walls are cross braces. Sheeting is another name for uprights. Butted together, these members are called close sheeting. Shielding is designed to give employees a safe work area by protecting them from collapsing material. Shielding can be either pre-manufactured or job-built under the specifications of a registered professional engineer. Shields used in trenches are called trench boxes or trench shields. These are usually portable steel structures placed in the trench by heavy equipment. In deep excavations, trench boxes can be stacked and attached to each other with stacking lugs. Using steel sheeting to extend the height of a trench box is unsafe because it overstresses the box. The professional engineer who designed the box is not responsible for its safety if the system is misused. Shields are installed in a way that restricts side-to-side and other hazardous movement. No one is allowed in the shield while it is being raised or lowered into place. Shielding or sheeting used with sloping must extend at least 18 inches above the bottom of the sloped part of the excavation. When using shores or shields, tabulated data provided by the manufacturer or a professional engineer must be followed regardless of soil classification. Any deviation must be approved in writing by the manufacturer. Installation and removal of a support system are safest when done from outside the trench. Individual shores are installed and released slowly to prevent failure of the remaining protection. Excavations must be backfilled immediately after support systems are removed. Occasionally, an excavation is subject to hazardous atmosphere. This can occur when digging near a landfill, in a sewer, or other toxic site. Air will be tested to ensure that it is made up of at least 19.5% oxygen and not more than 23.5% oxygen. Explosive, flammable, poisonous, corrosive, oxidizing, irritating, oxygen deficient, toxic, or otherwise harmful atmosphere will be tested and controlled before you enter the trench. Ventilation and use of personal protective equipment are two means of controlling hazardous trench air for your safety. Underground utilities are located and marked by the appropriate gas, electric, or other company before excavation starts. Excavated material and other objects must be kept at least 2 feet from the opening. No one works on the sides of sloped or benched excavations above other employees unless the lower worker is protected from falling material. No one is allowed underneath loads handled by lifting or digging equipment. No one except the operator is to be close to a vehicle being loaded or unloaded. Barricade tape draws attention to the work zone, but does not serve as a physical barrier to keep people and vehicles out. Trenches 4 feet deep or more must have a safe means of exit, such as a ramp or ladder, within 25 feet of every worker. Hard hats are required in any work zone, and vests are required when working in a street. Any excavating under the base or footing of a foundation or wall requires a support system designed by a registered professional engineer. A top person who observes trench work from outside the excavation can detect moving ground and warn workers to leave the trench until hazards are controlled. Before you go to work in an excavation, know what you're getting into. It can be done safely if you know about soil classification, protective systems, and conditions that can weaken the protection. It's up to you to work safe.